Moving to question number 2. The question number 2 says that the equation x square plus k equals to 6x has two real distinct roots. Distinct means different. They have two real distinct roots. If it is that case, that means the discriminant b squared minus 4ac should be bigger than 0. Whenever we have the case where discriminant is either bigger than 0 or it is less than 0, we will have a range of values for the unknown that is involved. If your unknown is k or unknown is p or any other number m or n or whatever, you will be asked in the question that find the range of that number. Okay, because that number can have very different values, so several possibilities would be there. It's not the case that it would exactly need to have one single value. So the same way they have asked that find the range of the k. So the unknown that we have involved in this equation is k. They have asked for the value of k. The range of the values of k means k would get multiple values. So we convert equation into a standard form. We take 6x to the same side so that we have equation equal to 0. We have x square minus 6x plus k equal to 0. That means our leading coefficient a is 1, b is negative 6 and c is k. The condition that they have given is two real distinct roots. Distinct means different roots. In that case, discriminant should be bigger than 0. So we plug in values in b square minus 4ac and we set that bigger than 0. This will get 36 minus 4k is bigger than 0, or we would say 36 is bigger than 4k. If that is the case, it means 4k is smaller than 36, right? If I am bigger than Jamil, that means Jamil is smaller than me. We can say it differently, right? We divide 4 on both sides, knowing the fact that 4 is a positive number. If you divide an inequality with a positive number on both of the sides, the inequality remains the same. It does not flip. If you divide with the negative number on both sides, the inequality will change its sign. So for now, we are dividing both sides by 4. That will have no harm, no effect on the inequality. So 4k is divided by 4, we get k. 36 is divided by 4, we get 9. Now k is lesser than 9. The range of the values of k that satisfies this equation is to choose k smaller than 9. You choose any value of k smaller than 9. So you can take 8.99999. You can take 8.9, 8.5, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, and so on and so forth up to negative infinity. Of course, you cannot touch negative infinity. So the range of the values of k would be from minus infinity to 9. 9 is not included because our k is lesser than 9, strictly less than 9, not equal to 9. If we look at the number line, it would be like k can have any values other than 9 and below 9. So you just skip 9. We have a hole on 9. 9 is not included. It is not a part of our range. You take any values below 9, keep going till negative infinity. We move to question number 3, and question number 3 says, question number 3 says that the equation 2 times x times p minus x equal to 3 has real and equal roots. That's very simple. So real and equal means discriminant is exactly equal to 0. We set that equal to 0. We convert equation into general form as always. 2x is multiplied with p, we have 2xp, minus 2x is multiplied with x, we have 2x squared equal to 3. We make a single equation. Our a value is negative 2, b is 2p, c is negative 3. We plug in values in the discriminant, and discriminant must be equal to 0 because the condition says it has real and equal roots. Equal roots means equal to 0. So we plug in values. We have 4p square minus 24 equal to 0. We solve the equation. We have p square equals to 6. If we take square root on both sides, we will have p equal to positive square root of 6 or p equal to negative square root of 6. It can have both values. So when the equation has the real equal roots, you will have fixed values for the unknown. Our unknown here was p. P got fixed values as the square root of 6 or negative square root of 6. We did not get a range of values. We will get a range of values if the discriminant is either bigger than 0 or lower than 0. When discriminant is exactly 0, we will have fixed values. We look at question number 4. Question number 4 says that find the values or range. Values in a case when your discriminant is equal to 0. where you have real equal roots. Range in the case where you have real repeated roots, real different roots, or you have non-real roots, when discriminant is either bigger or lower than 0 of p. P is our unknown for every equation. So the first equation has px square minus 6x plus p equal to 0. It has equal real roots. That means in the first part of question number 4, let me make a place here. In question number 4, first part, you will have to set discriminant bigger than 0. Then solve it, right? No, it has equal real roots. That means discriminant equal to 0. In the second part, it says it has real roots. It has just said it has real roots. Real what? Real equal or real different? They have not specified that. If you are not specified that whether real equal or real distinct, you will go with general case. See, if it is real and different, you will have discriminant bigger than 0. If it is real and equal, you will have discriminant equal to 0. So since we don't know whether they are real repeated or real different roots, we will take both conditions and merge them. So whenever the question says it just has real roots, it's not fixing whether real equal or real different. If it is not specifying that clearly, you would always choose both of the cases and merge them. So we will use the discriminant bigger than or equal to 0. It will again give us some range of the values for p. We'll find that. Okay, the third part says it has distinct real roots. Distinct means different, so that means discriminant strictly bigger than 0. The fourth part says it has no real roots. So if it has no real roots, that means discriminant less than 0. Now look at this one. It's a bit it looks a bit different, so let me simplify it for you. The equation says, whenever you have a condition like this which says p times x plus 1 times x minus 3 equal to x minus 4p minus 2. So we'll simplify this one. We expand it and simplify it as much as we want. So p multiplied with, we'll take x, distribute it over x minus 3. So x multiplied with x minus 3. Then we take plus 1 and distribute it over x minus 3. Right? This side we are keeping same for now. Then this will become p times x squared minus 3x plus x minus 3 equal to x minus 4p minus 2. We have p times x squared. If we subtract 3x from x, we get negative 2x minus 3 equal to x minus 4p minus 2. We multiply p with all of it. So we have px squared minus 2px minus 3 equal to x minus 4p minus 2. We take this whole on the left side to make one equation. We will have px squared minus 2px minus 3 minus x plus 4p plus 2 equal to 0. Combine the like terms. There is no term of x square, so we'll keep it as it is, px squared. There are two terms which include x. One is this one and the other one is this. So if I factor out x from here or negative x from here, I'll be left with 2p plus 1. So 2p is multiplied with negative x and 1 is multiplied with negative x. Then the rest is constant part, which is 4p. 2 minus 3 will be negative 1 equal to 0. So now my a is p, only this p. The b part is negative, this negative sign, and 2p plus 1. And the c part is this whole constant, which is 4p minus 1. Our condition is discriminant less than 0. So we take this a, b, and c, put it in b square minus 4ac, set that less than 0, and find the value of p.